All right. So good morning, everyone. Thank you for joining us on this lovely Wednesday. We have an exciting webinar today that's going to go over AI workloads with Ceph. How do we optimize it? All of that fun stuff. My name is Leanne Puller. I work in business development for CLYSO. I'll just be helping moderate the experts here this morning and managing the meeting. So welcome. All right, let's see here. So first, I'd like to give a special shout out to Tushar Gohad. He works with Intel. He originally planning on being on this call today, but couldn't make it. So he's been a part of the planning and the discussion so far, and he's added his impact. And we miss him today, but just wanted to give him a special appreciation shout out for the work he's done leading into this call. So far for our panel, we've got 4 experts here that you can see on the screen. Dan Vanderster, he is the Chief Technology Officer here at CLYSO. He's got over 10 years of experience working with Ceph as a user, as a developer. He's one of our Ceph gurus here at CLYSO. Next up, we have Mark Nelson. He is the head of our research and development here at CLYSO. He's a founding engineer at InkTank, also on the Ceph open source project. He leads the performance there. Lots of experience with Ceph as well. Next up, we have Federico Lucifredi. He is the Ceph product management director at IBM. He is an expert in cloud computing, and he provides lots of key insights into AI storage. So welcome, Federico. And last but not least, we have Kyle Bader. He is a principal architect at Red Hat. Again, another super experienced individual with Ceph, and again, offering lots of insights for AI operations with Ceph. So welcome all of you. Looking forward to today's conversation. This call, how we'll just go through here. Today, we're going to talk about a couple different topics. I have a couple questions that'll help guide the conversation, but really we're going to go over AI storage challenges and solutions. We're going to talk about performance optimization. We're going to discuss Ceph's role in the future for AI trends and what's popular today. And then really my goal is to just soak up all of the insights that you all in this panel have and your experience with Ceph. And really, we're just here to learn as much as we possibly can from you all. With that said, before I jump into our first question, I just want to say to everyone on the call, if you can enter all of your questions into the chat as they come through, then we will try and answer as many as we can if we have time at the end. And if not, we will gather all of the questions, we'll answer them and provide a written response over email after. And we'll also post this webinar. So if any of your colleagues have missed it, we'll let you know places that you can rewatch. All right. Are you experts ready for the first question? Here.
Are we using the Q&A feature or are we using chat?
We are not using the Q&A feature. We're just going to do the open chat. That way everyone on the call can see the questions as they come in and have full visibility.
Awesome, thanks.
So the first question that we'll start to get the conversation going is, what unique challenges does AI training and inference present for storage systems like Ceph? I don't know, Dan, would you like to start? Kyle, Mark, Federico? Who would like to start the conversation here? And I will also put these questions in the chat so everyone can see them as well.
Thanks. Well, I can say something, like just to start something, because I asked that same question, I don't know, 4 or 5 years ago at CERN when we started CERN is normally a high throughput computing place, lots of big files, big data, petabytes and petabytes of data, but throughput oriented. So how many gigabytes per second can you read the data? And then when AI, ML, and all this came on the scene, I was like, it was the same question. I was like, why is this challenging? What even is it? And like from a very basic fundamental, like very basic answer, it's about the number of files and like lots and lots of small files. And it changes. So to start the discussion, when you're training models, you have tiny files, like small files, maybe images, maybe other, bits of data. And that it puts a different kind of challenge on the metadata, system of the storage. So in Ceph world, this is Cephfs. If we're talking about Cephfs, and yeah, I don't know.
Dan, did you guys at CERN, did you look into like pre-processing the data very much? Was that like on your radar back then when you were just starting out with this, or was it like literally like huge like data sets of tiny files that like everyone did training on?
I mean, this initially was just about building. This kind of computing was a totally different. It was a totally different way of doing the particle physics analysis. So it was about building like a new model. So when we were building these first systems, we were using like the toy data sets that everyone else was using. So that was, I mean, later there's like more optimizations and things that can be done, of course, but this was just to sort of understand basically like what are we starting, like what kind of, everything until then had been about how many gigabytes per second can we get, even beyond that, like throughput, right? Which in retrospect is like, well, I don't want to say it's easy because it's not easy. It's hard. It's also hard, right? But metadata is more challenging, right? As we know.
Yeah.
I remember the first time I was like trying to run some like ML type things on Ceph. I think it was Cephfs, and I want to say it was like an ImageNet type workload, like it was some sort of SSD model, and like single shot detection, and so you have this ImageNet data set, and it's a bunch of images, and then it's a bunch of like tiny JSON files. Like this is the stupidest way to organize data that I've ever seen before.
Yeah.
Yeah.
And then I started to see that okay, some other people realized that this is probably not the best way to do this either, and that's where you see like the various serialization libraries. So there's like TF record or record IO, and like there's a series of other ones as well. And I think that kind of moves the things back to like being more throughput oriented, where maybe you're having splits that are like from a few megabytes to maybe 100 megabytes, or like if you look at like TF records, they tell you like aim for like 100 megabytes. It's like that sounds awesome from a storage perspective, right? But
yeah,
but we do hear about people that say, hey, like I have these data, I have people that have these disgusting access patterns where they have a workload that resembles a bunch of images and like JSON files that have like 2 lines of annotations in it. And you're like, oh, well. So I do think there's part of that too, because like if you're thinking about like the life cycle of AI, right? There's this ingest and data preparation stage that is part of that whole kind of experience. And even if you're able to like clean up and use these sorts of formats for like once you get to training, that's still part of like getting there is like you have to organize the data into those formats. And so it's like it is kind of like, oh, okay, you can maybe use your GPUs more efficiently if you use these formats, but like if that's the way your data comes, that's the way it is, right? So you still have to deal with it at some point, right?
Yeah. So it's interesting you mentioned. Go, Federico, go ahead, please.
Just a quick aside on what Kyle was saying. You can make a similar point at the slightly higher level, which is that nowadays you'll probably see new applications all designed around object, but file is still so common in AI, and I'm not going to say that it's bad design, but it's the prevalence of a research environment and what researchers are familiar with. If you're not a developer or a CS person, object storage is still some strange thing. So you default to file, and that's why you see so much file still in AI. Go on, Mark.
So yeah, I was just going to mention, Kyle, that with ImageNet, you brought up ImageNet, and that's really relevant for me. I did some work studying exactly like TF record versus using like a base image data set, specifically ImageNet. And yeah, the patterns that you see when you're doing like ResNet 50, comparing base ImageNet versus converting to 100 megabyte TF records is dramatic. It's huge, the difference in the underlying IO patterns that hit the storage system. This wasn't with Ceph.
Yep.
This was with a different storage system, but the amount of throughput that we could get and how quickly we could feed the GPUs was dramatic when you pre-process the data like that. So yeah, certainly there's a lot of nuance in what kind of behavior you're going to see depending on how you kind of set up your training.
I think the file thing is super interesting too, where, you know, like I kind of naturally expected everyone to use like object stores for AI, right? And I think it's partially the reason why file has grown so much in AI is just because PyTorch has gained so much popularity. And
Yeah.
and initially PyTorch didn't have any native way of using S3. PyTorch was like, oh, if you want to use S3, then like rewrite your application to use Bodo. And everyone's like, I'm not doing that. Like,
You're right.
Yeah,
Right.
yeah.
Of course. That's a good point.
they're like, I'm going to use like the file open thing or whatever. Whereas like if like I feel like if TensorFlow or if MXNet really took off and not PyTorch, like initially those both had like native object access. So it was just like I don't know if that's entirely true, but like it wasn't until I think earlier this year that like Torch data got like native support for object. Before it was always like, oh, you gotta modify it and make it use Bodo or something. And it was like the data scientists people were like, I'm not doing that.
So,
like, why would I don't care.
Yeah,
Like,
yeah.
just give me faster. Just give me a file system. Like, or I'm going to use like a Fuse.
I'll let the
I'm
production.
going to mount an
deal
S3
with
bucket
that
with
later.
Fuse and access it that way. And you're like, no, please, like, don't do that. Like,
This is like the most unfortunate thing of my career is like when I got started in storage, it's like all of object storage and things were, it was like, wow, we're going to change. Finally, we can get rid of POSIX. And it's like, even that was part of the Ceph dream, right? I mean, we started with Cephfs was the original, like Ceph was created by our good friend Sage Weil to like do better than Lustre, right, in HPC file systems originally. But it's been this continual set of disappointment after disappointment of users, application designers, and things like just expecting a file system. It's like, yeah. I don't know.
you look at the big dogs, right? You look like they're like OpenAI. They did that cool blog post on like using like massively scaled Kubernetes. I can't remember what the blog post is called, but they're like running 50,000 cores or something in Kubernetes. But in it, they're talking about like their workloads, and they're like, yeah, we do training on blob storage. I was like, yes, like okay, so like there are people that aren't just like recovering HPC people that are moving on to AI workloads, right? Like,
yeah.
Oh man. So on that note, I know that like the DAOS folks have actually tied in native libraries into PyTorch and TensorFlow, so you can directly access their storage without going through any intermediate layer. And I've kind of thought about doing that for Ceph as well, because we wrote like a native libcepfs backend for the IO500 benchmark. And it would not be hard to do that for like these other applications too, if we wanted to. So like that could be another route.
Like that's the way that you plugged in Cephfs into IO500. Is that?
Yeah. We wrote a native backend for the IO500. So for MD test and IOR to be able to talk directly, without going through the kernel layer. So like we totally could do that for some of these popular AI applications.
Well, not even for the applications. Like there's the checkpoint IO interface in like the lightning checkpointing for PyTorch or something. So we like if someone were enterprising enough to write a libcepfs plugin for that, then it could just like directly use it that way.
So I'm like that. So like the unique challenges about AI on Ceph which we know and love. Like, do we have some like consensus? Is it about the number? Is it about the number of things, or is it because for me, like the classical things like throughput and all of the other stuff like still exists. You got to have like flexible. You got to have a flexible system with like, I'm sounding like I'm doing a weird pitch. I don't mean to sound like this, but like you got to have a thing that do anything, right? You got to be able to do object and file. Block. Do we see block in these AI systems? I mean, anyway, everyone needs other stuff. Anyway,
Yes,
you do. Yeah, what
I do. And I'll tell you why. But
Mhm.
should we? I can right now if we want to.
Yeah.
Sure.
So like the whole reason for block that I think is super interesting is exactly what you were saying before, Dan, is about metadata, right? So like if your training sets are static, if they don't change, you could totally write out your entire training set into an RBD image, take a snapshot of it, a read-only snapshot of it, and then share that image as a read-only snapshot to all of your clients. And now metadata becomes much less of an issue because you're not dealing with Cephafest trying to have like shared metadata access across all of your different clients. If you built a pipeline around that, like using like Jupyter, right, had an entire workflow for setting up, like uploading your training sets and running your analyses, you totally could do that with RBD. It'd be super awesome.
Interesting.
I think it depends on the type of models too, because like you're right. A lot of models aren't huge in terms of the data that you train on. So there's like if you search for like IBM data pile or something, there's a slide where it's like an inverted pyramid, and then at the top it says like it's like the process of refining the data for like the one of the Granite models. I think it was like 13B or something, but like at the top of the pyramid, before they like do any filtering or something, it's like 6.5 terabytes. And then they like, tokenize it, and then they dedupe it, and then they take out like all the bad words and abusive stuff, and then like rip out all the markup and URLs and that sort of stuff. And then like what they're left with is like 2 terabytes. And they're training large language models off of 2 terabytes, which like from a storage perspective, we go like, oh, like compared to like big data and analytics and stuff, 2 terabytes is like super small, right?
Yeah, hey, it fits in memory. Why do you bother with distributed file systems, right?
Well, the first time I did, I think I was running MLPerf, like not the storage specific benchmark, but like just like the MLPerf benchmark. First time I ran it against Ceph, it was like, I can't remember which model we were doing. We did a couple, and the first model, what it did was it just read in the data set into like the GPU memory. And so like we were looking at the IO on the Ceph cluster, it was like beep, and then it was like bored the rest of the time for the benchmark. We're like, oh, that was like not very exciting.
I had to do the same thing. I was doing multiple epochs of training, and too much of the data set was fitting into memory, so it got really boring really fast. It was only like, the first couple or between each epoch, I'd have to like flush cache so that like it kept on pulling from the distributed storage. So that's like, in my mind, the big training sets are actually the really interesting ones. The smaller ones are kind of like, they're quickly going to move into memory. They're quickly going to be uninteresting for distributed storage.
Yeah, and I think like recommendation systems, I think are like if you read like a lot of the papers that like come out of Facebook and Google and stuff, they talk about these like training these massive recommendation system models and like how much how they need to move the processing onto the storage because like they have a fixed power budget for like GPUs and storage, and they can have like, they don't want to have their pie chart be like, this is my processing, this is my storage. So they're like, I'm going to collapse the processing and the storage because I need to like just in time process it so that I can, it's like they can't even pre-materialize it. So I don't know.
This is
I was going to take
Leanne is trying to wrangle us, guys. We're going crazy.
I was going to take the opposite view, which is that I think that the models that are interesting are the ones that are not so intensive about anything, because there is this constant fascination with the LLMs and the very large scale models right now. But those are, first of all, things that either are already prepared by someone else and you're not going to train, you're just going to fine tune, or they're too big to be something that you can afford, right? But regardless of whatever shortcomings one can pick at in AI, the technology is very interesting in terms of what it can do already in the small scale. In computer vision, we have had a leap that's absolutely amazing, and nobody seems to be paying attention to that because everybody is talking about this ability to generate text that mimics a person's ability to reason poorly. But to me, the thing that's really one of the things that are really amazing are the ability to do proper machine vision that is so much more reliable than we had just a few years ago. And those are really, really lightweight. They're not massive workloads. So there is plenty of opportunity in the lightweight space too.
I think yeah, go ahead.
I was gonna say I apologize because I want to ask Federico a follow-up question. When you talk about vision, are you talking about like pattern recognition, or are you talking about something else?
Well, it could be. There are a bunch of vision models. The ones that stand out to me are image recognition, because things were so unreliable 10 years ago, and they're so good now that you cannot even have a proper CAPTCHA that doesn't drive the human user crazy, right? So that has really been a quantum leap, and because it's overshadowed by all the marketing around LLMs, we don't really talk about it. But the fact that we can look at pictures and tell what's in them so much better is, to me, as a business person, as someone who's trying to find a way to use it in a corporation, that is something that we can definitely use.
And where will that go? Like from a business perspective, where like, you know, you more than any of the rest of us, you're thinking about the business side of this. Where is that gonna like lead?
Well, that's $1 million question, but I think
just 1 million.
What?
No, I think the thing is, I think the right framework to think about it is whether you're going to optimize, accelerate, or transform things within your company. So, I mean, you could try to do all three, but usually I prefer to focus on one thing. You can choose to optimize and use AI to optimize, so make your processes more efficient in some fashion, or accelerate, making your current product or service scale better in some way. So first one was about saving money. The second one is about making more money. Or the third one is transform, create some new service that you couldn't do before. And so it's kind of very specific to what your business is, whether image recognition or a chatbot or image generation or analysis of files of any kind, or I don't know, sentiment analysis or recommender systems, as you were saying. Which of these comes out really depends on what your business is. But I try to fit them in those three bins. Am I going to save money? Am I going to make more money? Or am I going to do something that we couldn't do before? And that's the way I would think about the problem.
So Federico, I think you actually started the perfect bridge to my next question. I'd like to kind of move the conversation into why is Ceph particularly suited for AI workloads? You've brought up a couple different use cases, so maybe we can talk about those in particular. Let's start talking about what's so positive with using Ceph with AI.
One thing that I can mention is a pattern that we've seen before in terms of software-defined storage, which is when a new technology emerges, the software part of the storage part of the house may be trying to catch up with what the organization needs. So I don't know, cloud is emerging now. The IT department is rushing to build your internal private cloud, let's say, or your Kubernetes cluster, whatever it is. They are no doubt behind schedule, or they're being given an unreasonable schedule, depending on truth is in the eye of the beholder. So what's the easiest corner to cut? Well, we'll use the storage we already have. And we saw this pattern a lot in OpenStack, going back to Korea, to Dan's keynote there. The long tail of usage of OpenStack storage, you see Ceph, the dominant choice, and then everything else that is used in production, about less than 10% or less than 5%, depending on which column you're looking at, of usage, and those are the storage we already have kind of users.
Yeah, that was the like that was we had Open Infra Summit in Asia. Open Infra Summit Asia was held in Korea in September. We were there, and I gave us a talk on the 20 years of Ceph, because it's our 20-year anniversary this year since the first commit. And yeah, part of it is like the OpenStack, Open Infra community keeps pretty good usage statistics on all the different plugins, right? For what's used, what different components are. And we were a decade ago when we started all of this with OpenStack at CERN, we were like, we always followed where the Ceph thing was, right? Ceph historically was always, we used to call it the de facto standard for the de facto storage backend for OpenStack, right? But I don't know, somehow, like, just personally, I kind of like lost the my finger wasn't on the heartbeat of that one to see how that curve. I expected like seeing probably
it's higher now.
probably like scaled down or something. Like people have moved on to something else. I'm like, no, it's like higher. Ceph is it's like more prevalent than ever. Like the number.
Well, you look at
the number was 83%. Yeah, it was 83% of OpenStack clusters use Ceph, and everything else, all the other
like
stuff, it like this
fighting for differentiation with like the x-axis, right? Like they're just like barely.
Yeah, like everyone comes back. You try. There are many compelling alternatives out there, right? You know, paid and open source and stuff. Not many. You know, a couple fives or something. In the end, you know, people come back to Ceph, and it's because we forget. Like we used to talk about we used to talk about Crush. We used to talk about like Paxos, and we used to talk about why is Ceph even cool, right? Like, but like we don't even talk about this anymore. What makes Ceph special? So that's the kind of like basic foundation of my answer, is like, why is Ceph particularly suited for handling AI workloads? It's like all the stuff behind the scenes that gives you that like flexible storage that lets you expand it out, lets you adapt to this and that. Oh, you need block now. Okay, there's block. You need some object. You need to, oops, like these servers have the wrong mix of NVMe and hard drives. Okay, we'll just buy a new set and like not just buy whatever, you know, next generation will buy, 6 months later, buy, change, slowly move the data around. There's no, like all those operational reasons that make it such like a dream to drive a Ceph cluster compared to everything else. Yeah.
I want to add.
I think we're drifting a little bit. We're
Mm.
drifting a little bit from the AI topic. I mean,
That's what I was gonna say.
Foundation.
OpenStack.
Foundation. I know. Bring it back, but for me, that's the foundation. It's like
it's the same. It's the same reasons, and and there's like a big discussion right now around open, like what constitutes like open for AI and stuff, and I think that there's like this there's this recently thing around open platform for like enterprise AI, and you know using like open source tooling for all the different parts of AI, and I think that you know similar to the OpenStack thing that Ceph will see you know good usage in people that prioritize that openness, but there is a lot of AI right now that is very much not open, and people don't care as much about that. And so I think that is perhaps one challenge that we'll have to do, is that we have to rise to the occasion. We can't like there's of course those cool like architectural elements of stuff like Crush and you know just how it scales out and how it can deal with like lots of files because it's algorithmic and all that kind of stuff. But you know in the MDS and you know whatnot, but you know there's like serious competition from storage, and there's like a lot of usage of the cloud that kind of makes it like, I don't know, you're not going to run like it's fairly challenging to run Ceph in a fiscally responsible way in the cloud, or really any sort of software defined storage system that even resembles Ceph. So you have our work cut out for us. Like don't
Leanne,
but I think in terms of using
and your previous question in one go.
To use cloud as a metaphor. However, the thing there is, as in cloud, you could have basically destroy the economics of your hybrid cloud, to use the current term, by saying, oh, I've chosen the latest compute fabric, but I'm just using whatever storage I have in-house, you can essentially cripple your architecture in a very similar way with AI if you don't pick the right storage, right? If it's the lightweight workload of the ones that I was saying that I like so much, then maybe it doesn't matter. But if it's something that is going to tax the storage in any way, you have to pay attention to the storage. I think that's the bottom line that we're driving at here.
Can we start to talk about some of the key factors that you consider when you're designing your Ceph cluster that are specific for AI workloads?
I think
Leanne, I'm going to try to answer your last question and your next question at the same time, if
Both
it's okay.
Go, Mark.
Yeah. So okay, we know that a lot of the big cloud vendors that are focusing on AI, like Lambda and CoreWeave and some of the other ones, they're thinking about how to support a huge number of GPUs with their storage system and how to like build that, right? And so it's tricky with a lot of the existing storage systems out there. Some of them are very fast. Some of the proprietary systems out there are really, really quick, but they don't scale well. Ceph scales extremely well, but it's kind of complicated to get it set up in a way that works, especially at small scales right now. It takes some insight to be able to do that. So I think a lot of kind of what we need to focus on right now is both how do we kind of make that easier, but then also how do we integrate into the kinds of pipelines that they want to build. A lot of people that do AI don't know Linux. They don't want to work on a command line. They don't want to have to run things. They want, run things manually. They want to be able to just submit their work, have the AI be transparent in the background. The cloud vendors that focus on this want it to be virtualized. They want the storage to not be something that, like, they don't have to mount NFS on every single one of their cloud instances, for example. And that's the way that a lot of other vendors like provide their storage. So the advantage that Ceph has is that we can much more easily integrate into something like QEMU and provide like a virtual file system layer, or provide an object layer or some other layer that lets the storage be utilized in kind of the way that they want. And if we can capitalize on integrating this into the kinds of workflows that will make it easy for users to do their work and do their AI work, that's going to be huge for us. And optimization is a piece of that too, right? Like, we know right now the virtual file system layer in QEMU is very slow. There's like a fuse based method for like abstracting that and virtualizing that. So the more that we can provide a very streamlined, optimized way of accessing the data through these kinds of standard mechanisms and abstracted mechanisms, the more that Ceph, I think, can become dominant in this area.
You're thinking of a model as a service kind of.
We need to be friendly. We need to make it so that Ceph can be easily utilized in that way. Like, that's I think critical for us, is to make it so that, and we can, right? Because we're open source. We can work with those guys to do this. So yeah.
So like earlier on, like I was saying that like the main thing about AI for me like is from the very whatever, it's all the number of things. So solving number of things means you need scale out, right? So how, like, I'm curious, what do you, like, I know what Mark does really well, but like, what do you guys do? Like Kyle, Kyle, Federico, like what do you, if we're doing like, you want to design, like Leanne's question is, how do we optimize it for AI workloads? That sort of means like sort of planning, I think, for the future, or maybe having like how do you co-design Rados gateways with the backend to make it match and get the throughput or like ops per second that you need? Or like, how do you plan out CephFSs? So, CephFS, I think people, I don't know, in this call, there's a lot of familiar names. People are familiar with Ceph. People are probably new to Ceph, a big mix, but in all of Ceph's components, it's scale out, horizontal scale out with details, because we know the deep internals, which like is not always what's written on the white papers, right? But like, what do you guys do? Yeah.
Well, I don't know. I've done a ton of work with object, a ton of work with like analytics, and I would apply a lot of the similar things for AI, especially, and a lot of them are transferable to, or relatively transferable to Ceph, right? Because it's underlying like Rados at the end of the day. Like one of the more demanding things I think is probably like checkpointing, right? So if you have a ton of GPUs, right? So even if you have like 1,000 GPUs, right? The amount of data that you have to checkpoint for a model is, I think it depends on the number of parameters in the model, but like it's several, like if it's like 1,000, it might be like 4.5 terabytes of information, or it might be 20 terabytes of information, or it might be like if it's 20 terabytes of information and you need to checkpoint it, like I think NVIDIA tells you to checkpoint like minimally every 4 hours. Some people want to checkpoint after every epoch, right? Like it just depends on what their sensitivity is. But if you have to checkpoint every 4 hours, then you if you want to keep the amount of time that the GPUs are like idle minimized, if you wanted to keep it like 1% where like the GPUs are not doing something because of your checkpointing, because you can't proceed to the next check, or you really don't want to proceed to the next epoch until you've checkpointed it, right? So like you have like a 60-second window where you have to write out 4 or 20 terabytes of data if you want to keep your utilization, like your idle GPU utilization, under like 1% or something,
That's 333 gigabytes per second.
It's like fairly significant, right? Like it's a lot. And if you're running object, you're gonna have to scale out. You're gonna have to run a lot of RGWs, right? You're gonna have to have a load balancing, layer to handle that. And for write workloads, people always are kind of like surprised when I say this, but like for write workloads, erasure coding is actually better if you want to maximize global throughput, because you're writing less disks, or you're writing less data to disks. Yeah. And it's like, I thought erasure coding was slower. I was like, well, like we have to break up the data, and it like amplifies the number of IOs, but it reduces so in terms of like the number of IOPS that are hitting the disk, like it's higher, but the amount of data written is less. And so if your main goal is to optimize the total aggregate bandwidth, then erasure coding is good. But it like depends on how the checkpointing is done too, and how many GPUs you have, because like some of these workloads they'll have like a handful of threads that'll be doing the checkpointing, and so you actually do care about latency, because you can't just overcome and get more throughput by through parallelism, right? Like there's like Ceph loves parallelism, but if you can't get it because you don't have enough GPUs or something, then it's gonna boil down to your synchronous latency, and then that's when you have to go
I think to up level a little bit for those that are new to Ceph, the idea that everything in Ceph is scale out means that we can essentially size the cluster to what the workload needs, right? So once we know how much your workload needs to write, we can design a cluster that can take those writes. And that's generally a theme around Ceph, which is that you can design to the metrics that your workload needs. And we touched on this earlier, but I guess it bears repeating because it's unusual. In Ceph, you can scale your metadata capacity independent of your storage capacity, which is not a common thing for those that are still in file system land. But that's another example of the same thing.
So thinking ahead in future trends with AI, what type of requirements are you anticipating for any of the AI workloads, and how do you think Ceph is meeting those requirements?
Well, certainly.
So the most obvious is
the
most obvious. Sorry, Mark. Mine is going to be much more banal than yours. The most obvious is, as part of that transition from file to object that we're all hoping for, Ceph stands out because it can do both, right? So someone that maybe still has their feet in file but someday will join the modern world and use object. Well, they can choose to use Ceph and start in one mode, the same storage becomes the other. You can use the capacity transparently. You have a single storage silo providing both. That is a great operational thing, and it lets you solve your internal organizational problem later or separately from your procurement. Mark?
I was just going to say that the trend, the first thing that came to mind when Leanne, when you asked that question, is that the scale of data sets is exploding. The amount of data that we process, right? Like you think about, it's like self-driving cars and the vast amount of data that involves. And while like local memory per node has been increasing as well, I don't think it's been increasing at the same rate that the amount of data that we process has been increasing. So like, when you think about these massive data sets, you need a distributed storage system like Ceph. You need something that scales, that can provide a massive, single namespace that you can store data in. And that's like Ceph's bread and butter, right? Like there are other systems that are out there that are potentially faster than Ceph, or at least they claim they are. I don't know if it's actually always true, but they certainly have good marketing and say that they're faster than Ceph. But very often, they cannot scale anywhere near as big as Ceph can. So, as we see these problems become bigger and scarier and harder to solve with more data, I think Ceph has a real big opportunity there to really be able to provide the storage for those use cases.
Yeah, we have like, we know in detail, like on paper, everything scales out, but in reality, okay, at the Rados layer, that's pretty true. There are some limits, but they're very large. They're like, let's say, they're limits for like, say, 5 years from now. At the Rados gateway, those scale pretty well, right? Sometimes you maybe should use many buckets or something like that, because there's still some stuff that's shared in some cases, but CephFS was always more challenging, right? And I think, yeah, like the head of OpenStack at CERN, Tim Bell, he said like we were being a little bit too adventurous. We were like so adventurous with CephFS at CERN. Like we had the first, I'm all fuzzy, I don't know what's going on. We were doing like multi-MDS with like 10 MDSs, I don't know, like 6 years ago.
A decade ago.
A decade, I don't know. I don't know what was in the cheese over there, but doing crazy stuff, yeah. But like, okay, all of the like in the way that CephFS handles multi like scale out metadata servers, there's a lot of clever code in there. But lately there's a lot of clever code that wasn't that great, let's say talking about like 5 years ago. But it's really nice to see now that code like really stabilizing, and we see like, what do you guys see? I see in the wild like 10 MDSs, like 5 MDSs is kind of normal now. 10 MDSs it happens, but also like having Ceph with multiple file systems in one cluster, that becomes common now that I see more and more. So like, so you can have like so you can do scale out CephFS. And then I've seen like my favorite PRs that never got merged are some kind of like changes to the way that CephFS scales out the metadata that will, I don't know. I'm trying to think, like, I think we need to plan for CephFS that can run like 100 metadata servers or 200 metadata servers. There's a hard-coded max in the code. I think it's 255 or 256, one of those two.
Sure.
Maximum, yeah. Thanks, Spencer McPhee. The hard code is 256, exactly. Yeah. Like, I want to see that. That's not that big of a number, right? That should be. So that for me is like what we should be. It's part of what we should be working on. Yeah.
I've done 120, Dan.
Oh yeah.
80 is where everything starts. At least the last time I tried it, 80 was around where things start getting wonky. Yeah, it's not doesn't work real well. But yeah.
Is that what like ephemeral like there's all this like, oh yeah, we did all this like automatic subtree partitioning stuff, but to me, I always just like the elegancy and the simplicity of just like ephemeral pinning, right? And like Mark, you did that work like with like the IO 500, I think, and you were able to like kind of see some of the, or I think that either led to it or it was like the first time someone used it or something like that. But I always like that approach, and I feel like if you're going to have like
Yeah.
256 or more MDS, that something simple like that.
There was that famous patch that I talked about. Like it's complicated, so it's not merged yet, but it goes even beyond that. It was actually it was from a former developer. I mean, I don't need to say exactly what it was, but like it hashes the inode number and then decides which one. It's like down.
Yeah,
it's not even.
yeah.
We have lots of pinning techniques that go by directory and subtrees and stuff. This one like takes it to the ultimate level.
This is like Crush.
It's like Crush.
Yeah, exactly.
It uses the same function, actually, the same hash.
It uses the Jenkins,
guys,
whatever.
we could spend another entire, I think, webinar talking about Cephfs strategy. Yeah.
Yeah.
Well, so actually, this is perfect timing. We have about 10 minutes left till the top of the hour, and I just want to remind everyone who's joined us on the call today, please enter any questions you have into the chat. We are happy to continue the conversation. We'll answer all your questions, send you out that information over email. And I think with 10 minutes left, I say we take a question out of the chat that's come through so far. So I guess to kind of close it up here, let's see. Brian, thanks for writing that in. So what does it take to get started with Ceph, and what are some of the expectations regarding time and resources? I know that's kind of taking us back a little bit, but I think it's a valuable question for those folks with different levels of experience with Ceph on the call. Maybe we can end on that note.
Well, I guess one thing there that I want to say is it's actually fairly easy to get into Ceph. It's not that hard to deploy a Ceph cluster. With Ceph ADM now, it's fairly straightforward. The problem that I see is that if you really want to make a Ceph cluster that performs really well, you have to start planning kind of from the get-go what kind of hardware you're going to deploy on, balancing out the cost of different things versus the kind of the performance you want to get, and thinking through a lot of different moving pieces. And that's both on the hardware side, and to some degree it's also on the software side. So it's actually partially how we make money at CLYSO is that we assist people in this kind of thing. But in general, for Ceph to move forward and to be more popular and expand our ecosystem and our pool of users, we have to improve it. So to the extent that we can, helping people understand what to deploy on for their use case and how to do it well certainly is something we can do. Having said that, you can deploy Ceph on Raspberry Pis. So it's, Ceph will run on anything. It's just a question of how to make it run fast.
Right. I had a customer that, I think a current customer that's like a top 10 global bank. And the quote that they gave me was, we built our Ceph cluster using servers that had been rejected by our existing storage product. And it always worked and never lost any data, and that got our attention. So you can build a Ceph cluster using scrap, literally, but that doesn't mean that it's going to be a well-tuned cluster. And you have to decide how far you're going to go in terms of chasing perfection. I think the Linux kernel is a good example. You can get a pre-built distribution, RHEL, Ubuntu, whatever you. Deploy it, install it, and you hardly know that the kernel is there. Or you can go and build your own kernel and obsess about what exact symbols are going to be compiled in here, what options are going to be in there, and save a few kilobytes of RAM because I don't know why, but if it's an embedded system, you could do that. You have to choose based on what is your return for the effort, right? So you have to decide what the objective is. In terms of AI, I think we touched pretty clearly on the fact that the throughput is going to be a relevant bit, that metadata operations will be relevant if you're using file. So you have to choose what is your target and then go for that rather than trying to optimize across the entire spectrum, because Ceph has as many levers and knobs to turn as the Linux kernel. unless you intend to make a career of Ceph, you have to let somebody else pick your choices for you, those choices for you, and offload some of the problem from you.
I'd say if you take away anything about Ceph for AI and you want to get started, there's like one thing that you need to keep in mind, and that is use SSDs, right? Like I think it was like 10 years ago, what was it? I forget his name, Arthur from Fastly. He did that presentation at like Velocity where he was like, you know, SSDs were like a couple years old, and he was telling everyone to use SSDs, and he's like, you are on a bicycle right now, and like you don't need an F1 car, but like get in a car, right? You know, like
Yes, that's right.
Like when we were talking about the workloads, we're saying like is you know, a lot of times it's not a ton of data, and like when you're checkpointing, yeah, there can be a lot of data, but like the amount of throughput that you need relative to the space, it's almost crazy not to use SSDs.
Yeah.
If I can add one thing, so
Go for it, Dan.
well, it's okay. You'll probably come back to the SSD thing or something, but like my thing is more like if you want to start with Ceph now, it's like talk to people, talk to other organizations. Like part of this thing, it's open source, right? That makes the software better, more features, more hardened, whatever, more reliable. But also, like, don't forget, we have like part of why Ceph so successful. We have that mailing list where everyone's there sharing info, sharing experience. We've got Ceph days everywhere. We've got Cephalicon coming up. Like, share, find out. Don't like make the mistakes that others made. You know, don't repeat the mistakes from others. Like, like get some. The community remains like one of the main advantages of Ceph. So you can learn from others a lot, I think. Yeah. Back to SSDs, Mark.
Yeah. So Kyle, what I think will be really interesting going forward, right, is that yeah, we all know that hard drives are not going to be great for this use case. But the interesting piece, I think, is going to be looking at like, okay, QLC, flash, how cheap can we go? How close can we get to hard drive levels of cost while still making you know, sure that, especially for like read-oriented use cases, like QLC is great, right? But from the right side, if you've got like a 16K IU, is that good enough? Indirection unit, basically the minimum allocation size on the SSD, you know, is that can be good enough to keep up with like checkpointing workloads? Like if you've got lots of small things that you're checkpointing, do you need TLC? These are the kinds of things that like are going to be super interesting going forward as we look at space and cost and performance, you know, all of these things.
Yeah, QLC.
And you don't need to keep the data sets that, so you create a storage pool and you're working on it, there is going to be some dead data there. And if your storage pool is tuned for performance, you don't need to waste some of it for data that you're essentially archiving there. At IBM, we've been working on tape offloads, which is kind of the extreme scenario of that. But you can move it to any sort of cheaper storage and archive there. You don't need to keep the things that are not part of the live data set in your top tier storage.
And even in terms of hard drives, right? Like you could imagine that if you've got data that you convert to TF records and they're big 100 megabyte contiguous data sets, you know, maybe offloading like colder data sets onto hard drives isn't the end of the world, right? Like there's like a huge world of stuff out there that we could look at. So yeah, it's very interesting.
Modern hard drives have that smart. I mean, are we ending? Yeah. Modern hard drives have that hidden hybrid layer in front as well now. So maybe, I don't know what's coming next for spinners, but maybe there will be like more of that hybridness, high capacity. Still seems that for the cost per capacity, it's I don't know how that curve is going, but it still seems that cost per capacity hard drives will stick with us for a while, right? But
I think so.
I think it depends. I think it depends.
I think that's another topic we can
We'll
have
have
a
to
Next webinar. Yeah.
We'll have to bring like some people from Micron and Samsung and Seagate. They can all duke it out or something.
Well, on
That'd be
that
super
note, we're at the top of the hour, so I just want to I appreciate all of you sharing your thoughts. I think this was very valuable. And a friendly reminder to everyone on the call, please again, email or put in any last questions here, and we'll email those out, some responses out to you. That this is recorded, so we'll also share the recording with you through email right after the call. But thank you to all 4 of you. You did fantastic, and I'm happy to join the webinar with you and your expertise.
Thanks, Leanne.
Till next
Yes,
you.
time.
thank you.
Thanks, Leah. Yeah. And thanks for everyone that joined.
Thank you, everyone.
Yep. Thanks,
Everyone.
guys.
Thank you.
Bye.